So now that we know what we want to build, we have this basic system here. And for this demonstration, what we're going to do is we're going to build the base class as well as one subclass, the CPU. We're not going to worry about the hard drive because once you've built the CPU, it's pretty much the same thing to do the hard drive as well. There's no real difference other than specifying the information and modifying the getData string function as needed. But so we're just going to focus on the part in the CPU. But of course, as in all of our other object-oriented programs, there needs to be a driver class, and that driver class is pretty much what runs everything. So for example, in Kaboom, you have your world class, and the world class owns the bombs, and it owns the enemy, and it owns the buckets. So everything and all the interactions in between run through that driver class. In this example, we're going to have a driver class, and we're going to call it store. And that store, of course, because we're trying to build a computer store, is going to own all the parts. Now, some of those parts may be generic parts, or maybe they're CPU specifically, or maybe they're hard drive parts, whatever. It doesn't really matter. So, looking at the basics, we see I have a basic store here, it's class store, and this is where my driving is going to occur. Now, right now I don't have any functionality because I don't have any of the other classes. So whenever we want to set up an inheritance structure, we're going to start with the base class, or the parent class. And my parent class, according to my diagram, is the part class. So let's build that part class first. So the first thing we got to do is we have to actually create a class. So we're going to right click on Computer Store, we're going to add a new class. And we're just going to call this part. And we can see we have the basic setup. There's nothing too special here, and all we need to do now is start adding in all the same stuff we've always added: attributes, constructors, and behaviors, and any accessors and modifiers that we need. And we're going to keep things simple for this one, so we're pretty much just going to, because if we look at our functionality, all there is some attributes and one behavior. We also need to add the constructors in there, but not too many accessors and modifiers, because we're going to handle that in another way, as you'll see in a second. So when I want to create my data, we have 4 pieces of information. We have our manufacturer, our SKU, our description, and our cost. So our manufacturer, string manufacturer, and then we have our SKU, then we have our description, and then we have our cost. That's going to be a double. Now notice that I haven't added any access modifiers on here, no private or public. And that's because I need to introduce you to the third type of access modifier, and that is protected. So protected is kind of in between private and public. So if private says only this class can see and access this stuff, and public is all the classes that have a reference to this class can access this stuff, protected is in between. Protected is essentially private except for the fact that its children can also access that stuff. So if I make manufacturer protected, an external class would not be able to see manufacturer. However, all the subclasses of part would be able to. So I'm going to make all of this data protected. And then we got to make our constructors. Now I'm not even gonna bother with a default constructor. You can build one if you want, but they're not always necessary. If you're never going to use it, there's no sense in actually building it. I'm just going to do the overloaded constructor, which is essentially, if you remember, the constructor with parameters. So we're going to say public part, and we got to specify all the data that we're going to be setting up. So what we have here is our manufacturer first, so string manufacturer. Then we have our SKU. Then we have our description. And then finally we have our cost. And inside of here we're just going to set up the 4 pieces of information just like we did in the previous example. This dot manufacturer, this dot SKU equals SKU, this dot description equals description, and this dot cost equals cost. So nothing too special here, it's exactly what you want. And if you remember our diagram here, we have this string get data subprogram. This get data subprogram is built so external classes that have a reference to the part class can actually call this functionality. So if I say public get data, that means external classes will be able to get this. Well, sorry, I forgot to put a return type on here. So what this function is going to be able to do is just return a formatted string of all of the data available. So we'll just keep it very simple. Return. And we're just going to align it so each piece of information goes on a new row. Manufacturer, just to make sure that it's pretty to look at. Now you don't have to drop it down to the next line like this. I just do for readability purposes. Just makes life easier. It's good style, good design. Oops. And one last piece is the cost. Pretty consistent, put a capital there. And that's the end of the subprogram. This is actually the end of the entire class. So we've completely built our base class with all of its functionality as well as all of its data. So now this is where the inheritance comes in. This is where we start to build the subclass, and the subclass does what we call implements the base class, right? So it inherits from the base class. So let's go down and we're going to have to build that subclass. We're going to say right click and add new class. It's still just a regular class. There's nothing too special about it. We're going to name it CPU, standard mixed case format. And we see that it's exactly the same. Where do things change? Well, I need to tell C# that this class is going to inherit from another class, and I do that on the class line. I do that by putting a little colon here, and then the name of the class that's going to be its parent or its base class. In this case, that is going to be part. That means that all of the protected data and subprograms that are inside of part are now accessible here in the CPU class. So, according to our diagram, CPU has two pieces of information: speed in gigahertz and number of cores. So let's create those. So this is going to be private data because it has no children, or it's not going to have any children, and we want to keep using encapsulation. So I'm not going to change that in any way. So we're going to have double speed. Oops. Oh goodness. Gigahertz. And then we're going to have private int num cores. And now we got to go down to the constructor, and now this is where things can get a little complicated when you're trying to do the constructor of a subclass. So what we first want to do is we want to treat it just like a regular constructor, just like CPU was its own class with no inheritance whatsoever. So let's think about this for a second. We know it's got to be public and it's got to be named after the class. But what parameters do we put here? Do we just put speed and num cores? No, we actually have to put all the parameters that we want to be specified. That includes all the parameters that the base class requires as well. So the manufacturer, the SKU, the description, and the cost, they all need to be specified as well. So just to be consistent, I'm also going to specify them in the same order as the base class. So we don't want any confusion for the programmer later on. So we're going to follow this same pattern: string manufacturer, and then string SKU, string description, string double cost. Now that I have the four pieces of information from the base class, I can start specifying this class's information. So speed in gigahertz. Oops, I better do a data type first. Double speed in gigahertz, and int num cores. Now, normally from this point, we would just come in here and start specifying all the data. We'd say things like this.manufacturer equals manufacturer and all that kind of stuff. Now, the problem is it doesn't work like that. We need to essentially call the constructor of the base class. And that's why you see this is highlighted right here. It does not contain a constructor that takes 0 arguments or anything like that. So we need to actually call the constructor of the base class. And the way that we do that is on the same line here, kind of like where we specified here, a colon, that this is inheriting from part. We need to say that we're also going to call the base class constructor. So we say colon base. Base is a keyword that represents base class. And in this case, I'm actually going to do the constructor for it. So you can see as soon as I open up the brackets, all the data is visibly shown as what it's required. So as I specify this information here, this is actually taking in the, what did I spell wrong there? This is actually taking in the parameters that I was just getting from over here. So I can just take this information and pop it in. Oops, and this one, description, and then cost. You can see, now sometimes this can actually get pretty long. You can see that I can't even see it on the screen right now. So what you may want to do is just kind of take this and put it down on the next line so you can actually see it. That is just a style choice. It is completely up to you. It is acceptable to put it on either this line or on the previous line. It's just that sometimes the previous line will actually, the signature line of the CPU constructor will get pretty long depending on how many parameters you have. So you got to be careful. Readability always comes into play. And then I still specify the 2 pieces of information that are specific to the CPU here. So we could say this dot speed in gigahertz equals speed in gigahertz, and of course this dot num cores equals num cores. And last but not least, we just need to implement that last subprogram. If we look at the document here, get data as string. Public string get data as string. Now, if you remember, I specified, or I stated earlier, that we can now access any of the data from the base class that's protected. So, for example, I could write in base dot, and you can see that I can access all that information, cost, description, manufacturer, etc., that is protected or public inside of the base class. So this can actually be pretty useful in this case. So I could manually go through here and say, you know, return manufacturer colon plus base dot manufacturer, and I can continue on and do the exact same thing that I just did in the previous one in the base class. But why reinvent the wheel? In the base class, we have a subprogram called getData that does all this for me already. So what I'm going to do is, instead of reinventing the wheel, I'm just going to call that subprogram base.getData. And now I'm going to continue on to this. So I'm extending. So this is that code extensibility we talked about. I'm extending upon this to finish the functionality. So now I can continue adding my speed. And then on top of that, we got to finish off with the number of cores. And we've completely finished our subclass now. So all of our classes are built. All that remains is to set up the driver class. What can the driver class do? The driver class is what actually implements everything. So let's try this out. Let's say I wanted to create a generic part. I'm not creating a CPU, I'm just creating a part. So just like when we created a bomb, I have to specify the object and give it a name. So I'm just going to call this generic part equals new part. And now I got to specify all the information, as you can see here in the IntelliSense. So I'm just going to give it, I don't know, let's give it maybe it's an Apple product, and a SKU of just a whole bunch of numbers, doesn't really matter. and then a description. This is a generic part, and then a cost. Let's make it $9.99. No, this is Apple, so not likely, but anyways. So now we've created our generic part. Now if we wanted to, we could display that information for that part on the screen. Generic part.get data. Now of course we need to actually do something with that, so let's put that in onto the console. And we better put a console.readLine at the end so we can actually read the text. Oops. And if we run it, what we get is all the information for that specific part. Apple, barcode, the description, and the cost. So this is great. Now what if I want a CPU? Well, we can extend this. We can add in a CPU as well. So let's say CPU, my CPU equals new CPU. Now watch what happens when I open the brackets. It asks for all of the information, not just the specific information for the CPU, but everything. So I need my manufacturer. So maybe this is an Intel. And another bunch of random numbers. And the description is the fastest processor on the planet. And then we need a cost. Well, if it's the fastest one, it's going to be pretty expensive. Let's say $800. And it needs a speed in gigahertz, 3.4 gigahertz. Sounds pretty good. And let's say it's a beast with 16 cores. So, now let's try something. So below here we have console.writeLine showing the generic part data. I'm just going to put in a blank line in here just to separate some stuff. Now let's do something very similar. Console.writeLine. Let's do my CPU dot get data as string. Now, if we run this, we get all of the information for the generic part and all the information for the CPU specifically. If you look at this, it has all the basic information, the manufacturer, SKU, description, cost, plus the specific information for that CPU. Let's try something. What if I do, instead of get data as string, I do get data? And I run this, you'll notice now all I get is the 4 part specific information. I don't get the CPU specific information at all. And the reason being is that I called the get data from the CPU. Well, the CPU, my CPU is actually a CPU. So it doesn't have that get data functionality. But because the CPU can access the get data from the part, that means it has access to it. So if we call get data from the CPU, that means we're going to get the functionality from the part class. And the part class only displays the 4 basic pieces of information. So it's not going to do the get data as string as we would expect. So that is inheritance in a nutshell. So today's practice work should allow you to actually implement this and try something fun and spectacular. Thank you.